Fear is one of the most fundamental emotions the human brain can produce. In psychology, we define fear as a biological and psychological response to perceived threat, an emotion designed to protect us. Deep inside the brain, the amygdala acts as a central alarm system. When it detects potential danger, it activates the limbic system and sends rapid signals to prepare the body for action. This process can happen even before we consciously realize what's happening. Neuroscientist Joseph Ledoux was among the first to map these fear circuits. His research showed that sensory information can reach the amygdala through two routes, a fast pathway and a slow one. The fast pathway sends raw, unprocessed data straight from the thalamus to the amygdala, allowing an instant, reflexive response. The slow pathway, on the other hand, takes the information through the sensory cortex for deeper analysis. This is why you might jump at the sight of a shadow before realizing it's just your coat on a chair. The brain always favors survival over accuracy. From an evolutionary perspective, Charles Darwin argued in The Expression of the Emotions in Man and Animals that fear is not a weakness, but a survival mechanism shared across species. The widening of the eyes, the tensing of muscles, the acceleration of the heartbeat, all these reactions evolved to help organisms detect and respond to danger quickly. What's remarkable is how universal these expressions are. Whether it's a human or a mouse, fear prepares the body to either fight, flee, or freeze, behaviors that increase the chance of survival. Physiologically, fear activates the autonomic nervous system. The heart rate increases, blood pressure rises, breathing becomes shallow, and cortisol, the stress hormone, floods the bloodstream. This system was first described by Walter Cannon in 1915 as the fight or flight response. Modern research has expanded this to include freeze and fawn responses, showing that our reactions to threat are more varied than simple aggression or escape. At the neurobiological level, the communication between the amygdala, hypothalamus, and brainstem happens almost instantly. This is what gives fear its powerful immediacy. Later, higher brain regions like the prefrontal cortex get involved, trying to interpret and regulate that initial surge. But by then, the emotional response has already shaped our perception. Studies by Ehrman and Meinke, 2001, found that fear biases the way we see the world. We notice threat cues faster and interpret ambiguous information as more dangerous than it really is. In essence, fear sharpens perception, but it also distorts it. It's important to distinguish fear from anxiety, though the two often overlap. Fear is a reaction to an immediate threat like seeing a snake on the trail. Anxiety, on the other hand, is the anticipation of a threat that might or might not happen. David Barlow, 2002, described anxiety as a future-oriented mood state, driven by the uncertainty of potential danger. Fear says it's here. Anxiety says it might be here soon. Together, fear and anxiety shape how humans perceive and interact with the world. They influence our decisions, our attention, and even our memories. They keep us safe, but they can also limit us, because the same neural systems that evolved for survival can, in modern life, overreact to symbolic or social threats. In this way, fear isn't just a feeling. It's a biological legacy, an ancient survival mechanism that still governs much of human behavior. Whether we're facing predators in the wild or a difficult conversation in the present day, fear isn't only something we're born with, it's also something we learn. One of the most powerful insights in psychology is that fear can be conditioned, shaped, and maintained through experience. In the early 20th century, psychologists like Ivan Pavlov and later John B. Watson demonstrated how neutral experiences can become linked to fear. Watson's famous Little Albert experiment in 1920 illustrated this vividly. He paired a loud, startling noise with the sight of a white rat. Soon, the child began crying at the rat alone, even without the noise. The fear had been learned. This process is called classical conditioning. When a neutral stimulus becomes associated with something aversive, it starts to trigger the same emotional response. What's more striking is how persistent this learned fear can be, even when the threat no longer exists. But fear isn't just learned through associations, it's also reinforced through avoidance. Psychologist O. Hobart Mora proposed the two-factor theory of avoidance in 1939. The first factor is classical conditioning, how fear starts. The second is operant conditioning, how fear stays. When we avoid something that makes us anxious, we feel relief. That relief acts as a reward, reinforcing the avoidance. Over time, this negative reinforcement strengthens the fear, because the person never gets to see that the feared situation might actually be safe. For example, if someone has a panic attack while driving, they might start avoiding highways. Each time they stay off the highway, their anxiety drops temporarily, but the brain learns, avoiding keeps me safe. This relief loop teaches the nervous system to maintain fear, not overcome it. Then there's generalization, the process by which fear spreads. If a person is bitten by a dog once, they may begin fearing all dogs, even gentle ones. This mechanism is adaptive in the wild, where caution generalizes to similar threats. But in modern life, it can lead to excessive avoidance and anxiety. Research on fear generalization by Dunsmore and Paz, 2015, showed that the amygdala and hippocampus work together to broaden the fear response to similar cues, even when the context changes slightly. The opposite process, extinction learning, happens when a person repeatedly encounters the feared stimulus without negative consequences. This doesn't erase the original fear memory, but it creates a new one that competes with it. The Rescorla-Wagner model, 1972, helped explain this process mathematically. Learning occurs when what we expect doesn't match what we experience. If you expect something bad to happen and it doesn't, your brain updates the prediction, gradually lowering fear over time. This is why exposure therapy is so effective in treating phobias and anxiety disorders. It's the science of giving the brain new, safe experiences. However, fear memories are unusually resilient. They're stored not only in the amygdala but also in the hippocampus and sensory cortices. This distributed network makes them harder to erase completely. Even after extinction, certain triggers like stress or reminders can bring old fears back. Neuroscientists have found that the original memory isn't deleted, instead it's inhibited. The body remembers. In everyday life, fear conditioning doesn't just happen with loud noises or dangerous animals. It happens with social and emotional experiences too. If you once felt humiliated during public speaking, your brain might tag that situation as unsafe, leading you to avoid it. If conflict once led to rejection, you might learn to avoid confrontation altogether. These patterns are subtle, but they operate under the same psychological laws as Watson's experiments. An association forms between an experience and a feeling of danger. In modern society, the threats have changed, but the brain hasn't. Today, instead of lions or snakes, we might fear embarrassment, failure, or rejection. And just like little Albert, those associations can spread and linger. Understanding how we learn fear and how avoidance maintains it is the first step toward understanding how deeply it shapes our behavior. Avoidance is one of the brain's simplest coping strategies and one of the most deceptive. It feels protective, even healthy, but over time it quietly strengthens the very fear we're trying to escape. Psychologist David Barlow, 1988, described this as the relief cycle. When we avoid something threatening, anxiety drops for a moment. That relief feels rewarding, so the brain learns avoidance works. But in the long run, the fear remains untouched or even grows stronger. Each act of avoidance becomes a small vote for the belief that we can't handle the situation. There are two main forms of avoidance. Behavioral avoidance means staying away from situations, not speaking up, not going out, not trying. Cognitive avoidance happens in the mind, distracting ourselves, suppressing thoughts, or rationalizing fears away. Both reduce distress short-term, but both keep the fear alive by preventing emotional processing. Brain imaging studies show that avoidance temporarily dampens activity in the amygdala, the brain's fear center. Research by Hartley and Phelps, 2010, found that this neural quieting reinforces avoidance behaviors, making them neurologically satisfying. That's why avoidance feels soothing, it calms the system quickly. But it also prevents learning. Studies by Salkovskis, 1991, on safety behaviors showed that when people use protective strategies, like carrying water during panic attacks or avoiding eye contact in social anxiety, they never fully test whether the danger is real. The safety behavior maintains the fear. In more chronic cases, avoidance can evolve into a sense of learned helplessness, a concept developed by Martin Seligman, 1975. When individuals repeatedly avoid or fail to escape stressors, they may stop trying altogether, believing they have no control even when they do. Avoidance isn't always dramatic. Sometimes it hides behind phrases like "I'm not ready yet" or "I just need to rest." While self-care is important, psychological avoidance often disguises itself as self-protection. Over time, it shrinks the space in which we live emotionally, socially, and mentally. Avoidance offers comfort now but costs freedom later. It's the brain's short-term solution to discomfort that quietly builds long-term constraint. Fear doesn't just live in the body, it also lives in the mind. How we interpret and think about danger determines how strongly fear takes hold. Psychologist Richard Lazarus, 1966, proposed the cognitive appraisal theory, which says emotions arise not from events themselves but from how we evaluate them. When we perceive something as threatening and believe we can't cope, fear emerges. If we believe we can manage it, the emotion changes maybe to determination or caution instead. So fear begins with appraisal. What's happening, and can I handle it? Distorted thinking patterns can amplify fear. Aaron Beck's 1976 cognitive model of anxiety described how people fall into catastrophic thinking, mentally jumping to the worst-case scenario. A small mistake becomes "I'll fail completely." A fast heartbeat becomes "I'm having a heart attack." The mind exaggerates threat and underestimates coping ability. Fear also hijacks attention. Studies by MacLeod and Matthews, 1988, showed that anxious individuals selectively focus on threat-related cues, scanning faces for disapproval or interpreting neutral comments as criticism. This attentional bias keeps the brain locked onto danger, filtering out neutral or positive information that could balance perception. Another layer is interpretation bias, described by Eysenck, 1992. When people are anxious, they interpret ambiguous situations, like a friend not replying to a message, as signs of rejection or hostility. The event itself isn't the problem, it's the story we attach to it. Over time, these patterns create cognitive loops. Fearful thoughts trigger anxious feelings, which then generate more fearful thoughts. This cycle strengthens neural connections between the prefrontal cortex and amygdala, making fear responses faster and harder to control. The mind essentially rehearses fear, training itself to react more quickly next time. Inside all of us is what could be called the internal narrator of fear, a mental voice that predicts danger, rehearses what could go wrong, and insists it's protecting us. But this voice isn't truth, it's a pattern built from past learning and perceived vulnerability. Understanding that the fear voice is a mental habit, not a prophecy, is a crucial step in weakening its hold. Fear at its core is as much a thought process as a biological one. Our interpretations shape its power. And by learning to question those interpretations, we begin to see fear not as an uncontrollable force, but as a story the mind tells, one that can be rewritten. To understand why fear feels so powerful, we need to look at how it's stored and remembered in the brain. Fear isn't just an emotion that passes through. It's a memory trace, a learned imprint that can be reactivated long after the danger is gone. At the center of this process is the amygdala, which assigns emotional significance to experiences. When something frightening happens, the amygdala helps tag that memory as important, a signal to never forget this. This emotional tagging makes fear memories vivid and enduring, often stronger than neutral ones. Nearby, the hippocampus provides the context. It tells the brain where and when an event occurred. Normally, this helps us distinguish safe environments from dangerous ones. But when the hippocampus is under stress or damaged by chronic cortisol exposure, as Robert Sapolsky, 1996, described, it can misfire. The result is fear that becomes disconnected from reality, such as feeling unsafe in a harmless situation simply because it resembles a past threat. The prefrontal cortex, PFC, plays the opposite role. It regulates and inhibits fear by reasoning through the threat. But under intense arousal, the amygdala can override the PFC, reducing our capacity for rational thought. This is why fear can feel uncontrollable. The brain's emotional center temporarily outruns its logical one. Neuroscientific research has shown that fear memories aren't static. Karim Nader and colleagues, 2000, discovered the process of reconsolidation, where reactivated memories become malleable again. If a fear memory is recalled and then updated with new, non-threatening information, its emotional charge can weaken. This finding reshaped how psychologists think about exposure therapy, showing that fear memories can be edited, not just suppressed. However, chronic stress complicates this balance. Persistent high levels of cortisol can damage neurons in the hippocampus and impair communication with the prefrontal cortex. Over time, this makes fear regulation harder, leading to exaggerated or prolonged fear responses. Finally, it's important to note the difference between implicit and explicit fear memories. Implicit memories are stored in the body, the quickened heartbeat, the flinch, the tightening of muscles. Explicit memories are the conscious narratives we can describe in words. You might know you're safe, but your body may still react as if you're not. That's because implicit memories operate below awareness, tied directly to the amygdala's learning system. Fear, memory, and biology are deeply intertwined. Our brains evolved to remember danger more vividly than safety because survival once depended on it. But in the modern world, this ancient design can turn against us, replaying old fears in new contexts. Understanding these systems reminds us that fear isn't weakness, it's memory doing its job, sometimes too well. Fear doesn't appear out of nowhere, it develops alongside us. From infancy onward, the way we learn to handle fear is shaped by our relationships, experiences, and even our biology. According to John Bowlby's attachment theory, a child's first sense of safety comes from the caregiver. When a caregiver is responsive and comforting, the child learns that fear can be managed. That distress leads to soothing and protection. But when that care is inconsistent or absent, the brain may encode the world as unpredictable or unsafe. This early template becomes the foundation for how we regulate fear later in life. Children also learn fear by watching others. In Albert Bandura's social learning theory, 1961, he demonstrated how modeling influences behavior. When a parent reacts with panic to a spider or with anxiety to social situations, a child's nervous system learns to do the same, no direct trauma needed. Fear is contagious because the human brain mirrors emotional responses it observes, especially during development. Temperament adds another layer. Psychologist Jerome Kagan 1997 studied infants with a trait called behavioral inhibition, those who reacted strongly to novelty or change. Many of these children later developed higher levels of social anxiety. Genetics doesn't determine fear, but it can set the emotional sensitivity level, like the volume knob on the fear system. Early trauma, however, can radically alter how fear circuits develop. Repeated stress or neglect during childhood heightens amygdala reactivity and weakens prefrontal regulation, creating a brain that's constantly on alert. The nervous system learns that safety is temporary, a lesson that can echo throughout life. During adolescence, avoidance often becomes more pronounced. Teenagers face new forms of social threat, judgment, rejection, failure, and since the brain's emotion centers mature faster than its regulatory systems, avoidance feels like the easiest escape. Avoiding embarrassment, conflict, or emotional vulnerability can become a default coping style that carries into adulthood. Fear can even pass between generations. Research by Diaz and Ressler 2014 showed that mice conditioned to fear a particular smell passed that fear to their offspring through epigenetic changes, not by teaching but through altered gene expression. Similar processes may occur in humans, where parental anxiety shapes both behavior and biology. In short, our relationship with fear begins in the crib, grows through imitation, and solidifies through experience. By the time we reach adulthood, our fear and avoidance patterns often reflect not just what's happened to us, but what's been passed to us through genes, family, and culture alike. Fear doesn't exist in a vacuum, it's shaped by the culture and society we live in. What we fear, how we express it, and how we cope with it all depend on the social environment surrounding us. Every culture teaches its members what counts as danger. Charles Darwin noted that emotional expressions are universal, but their triggers are learned. In some societies, fear centers around supernatural forces. In others, it's tied to failure, shame, or social exclusion. Cultural norms tell us which fears are acceptable to show and which must be hidden. A person raised in a culture that prizes independence may fear dependency, while someone raised in a collectivist culture may fear standing out or disrupting group harmony. Fear also plays a huge role in social life. Clark and Wells, 1995, described social anxiety as being driven by self-focused attention and inward monitoring of how one appears to others. This kind of fear is deeply social. We fear rejection, embarrassment, or loss of status because belonging is a basic human need. The fear of negative evaluation isn't irrational, it's tied to our evolutionary dependence on groups for survival. Modern media amplifies fear in subtle ways. Through constant exposure to threatening or sensational content, our perception of danger becomes distorted. Studies show that frequent news consumption can increase what psychologists call mean world syndrome, the belief that the world is more dangerous than it actually is. In this sense, the media acts as a global conditioning mechanism, shaping collective fear responses just as classical conditioning shapes individual ones. On a larger scale, fear can spread through societies. Sociologist Stanley Cohen, 1972, described this in his work on moral panics, moments when a group, event, or behavior is exaggerated as a societal threat. These shared fears can lead to stigma, control, or even policy changes. Collective fear isn't just emotional, it's political. Cultural differences also shape how people cope with fear and avoidance. In collectivist cultures, individuals might cope by turning to community and harmony, sometimes avoiding conflict to maintain social balance. In individualist cultures, fear may take the form of performance anxiety or perfectionism, a fear of not living up to one's personal ideal. Finally, fear can be used as a form of control. From propaganda to authority figures, institutions have long understood that fear motivates compliance. Stanley Milgram's obedience studies, 1963, showed how people could act against their own values when guided by authority and a sense of potential threat. Social fear, in this way, becomes a tool that can guide behavior on a massive scale. Fear is personal, but it's also collective. It's written into our stories, our rituals, our laws, and our media. And while culture shapes the form it takes, the underlying emotion, the feeling of vulnerability, and the desire for safety remains universal. Fear and avoidance are at the heart of many psychological disorders. What begins as a natural survival mechanism can, under certain conditions, turn into chronic distress. When fear circuits become overactive and avoidance takes control, mental health begins to suffer. In anxiety disorders, the fear system fires too easily and too often. The amygdala becomes hyperresponsive to perceived threats, while the prefrontal cortex struggles to regulate it. This imbalance is seen across phobias, panic disorder, generalized anxiety disorder (GAD), and post-traumatic stress disorder (PTSD). Each involves different triggers but the same underlying mechanism, an overestimation of danger and an underestimation of safety. In phobias, fear is specific and immediate, perhaps spiders, heights, or enclosed spaces. Avoidance maintains the fear by preventing exposure and learning. In panic disorder, the body itself becomes the threat. A racing heart or shortness of breath triggers catastrophic thoughts, leading to a loop of fear about fear. PTSD demonstrates how fear and avoidance can become deeply intertwined. After trauma, the brain's alarm system remains on high alert, and ordinary cues can trigger vivid re-experiencing. The DSM-5 highlights avoidance as one of PTSD's main symptom clusters, avoiding reminders, places, or thoughts related to the trauma. This avoidance offers temporary relief but blocks the brain's ability to integrate and resolve the traumatic memory. Obsessive-compulsive disorder (OCD) presents another variation. Here, fear is tied to uncertainty, fear that something bad might happen if rituals aren't performed. According to Stanley Rachman, 1997, compulsive behaviors like checking or cleaning are forms of avoidance meant to neutralize anxiety. But the relief is short-lived, reinforcing the cycle. Even depression often carries an element of avoidance. People withdraw from effort, decisions, and social contact, not always from sadness alone, but from fear of failure, rejection, or futility. Avoidance here becomes emotional numbness, a quiet retreat from potential pain. In more enduring personality patterns, such as avoidant personality disorder, fear becomes the organizing principle of life. The person deeply desires connection but avoids it out of fear of criticism or humiliation. This pattern reflects fear not of physical danger, but of emotional exposure, a wound to the self. Neurobiologically, these disorders share a common theme: overactivity in the amygdala, underactivity in prefrontal inhibition, and dysregulation in the hippocampus, which struggles to contextualize fear memories. Research shows that effective therapies, from exposure to mindfulness-based approaches, often work by restoring communication among these regions, allowing the brain to relearn safety. In essence, mental health challenges often represent the same ancient fear mechanisms misfiring in a modern world. Fear keeps us alive, but when avoidance takes the wheel, it slowly narrows life until safety becomes a prison. Recognizing this cycle is the first step toward loosening fear's grip. Not all fear comes from external danger. Some of the deepest forms of fear come from within, from our awareness of time, loss, and the limits of being human. These are existential fears, and they quietly shape much of human behavior. One of the most profound is the fear of mortality. Cultural anthropologist Ernest Becker, in The Denial of Death, 1973, argued that human beings live in tension between the drive for self-preservation and the knowledge that death is inevitable. This awareness generates a background anxiety that motivates much of what we do, the pursuit of achievement, love, legacy, or belief systems that promise meaning beyond the self. Closely related is the fear of the unknown. Uncertainty is inherently uncomfortable for the brain. Research by R. Nicholas Carlton, 2016, identified intolerance of uncertainty as a core driver of chronic anxiety. When we can't predict outcomes, the mind fills the gap with imagined threats. That's why people often prefer bad news over not knowing. Certainty, even painful certainty, feels safer than ambiguity. Then there's the fear of loss and change. According to John Bowlby's attachment theory, 1980, our emotional bonds become part of our sense of safety. Losing them, through death, rejection, or distance, activates the same neural pathways as physical pain. This fear of loss underlies grief, jealousy, and even resistance to growth, because every change carries a small death of the familiar. Emotions like shame and exposure also carry fear at their core. Shame is the fear of being seen as inadequate or unworthy, a deeply social form of threat. Neuroimaging studies have shown that social rejection activates the same brain regions as physical pain. This intertwining of emotional and physical fear explains why humiliation or rejection can feel almost unbearable. Sometimes people begin to fear not just situations or emotions, but emotion itself. Psychologist Stephen Hayes and colleagues, 1996, described this as experiential avoidance, the attempt to suppress or escape internal experiences like fear, sadness, or guilt. The more we try not to feel, the stronger those emotions become, because resistance tells the brain that what we're avoiding is dangerous. Yet meaning can transform fear. Psychiatrist Viktor Frankl, in Man's Search for Meaning, observed that those who could find purpose, even in suffering, were better able to endure it. Meaning doesn't erase fear, but it gives it context. When fear is linked to something we value, it becomes tolerable, even motivating. So while biological and learned fears protect the body, existential fears shape the soul. They remind us of our vulnerability, our impermanence, and our dependence on others. Facing them doesn't remove them, it reveals what matters most beneath them.